Right, next one.
That is so sorry.
Right, guys, here we go. New one here. 1 1/3 to the power of minus 2. 1 1/3 to the power of minus 2. Right, he is allowed to speak, but if anyone else has an alternative, I'll go with them for a minute.
I would make it into a top-heavy fraction.
He's right. So would you. Well done for saying that, yeah. Okay, if you've got a mixed fraction like this, change it into a top-heavy fraction. So 3 times by 1 is 3, plus 1 is 4. So it's 4/3 to the minus 2. Then just do what we have done before. First thing I suggest you do is replace the minus power there with a 1 over and just rewrite the question without the minus power. And remember, when you've got a fraction to a power, that power applies to both numbers in your fraction. So that's 1 over 16 over 9. That's 1 divided by, we do our keep, change, flip, and we get our answer. Okay. Oh, there's a nice one coming up next.
Callum like it.
Well, somebody who hasn't got so many numbers in it. It's got letters in it again. So, that says 2x squared y to the minus 4, all to the power of a half, and we are asked to simplify it. Right, so, now, just like before, just like up here actually, where we had a bracket with a power on it, and we said that power applies to each bit in the bracket, we can sort of do that here. And what I would do here is say that power of a half applies to the 2, it applies to the x squared, and it applies to the minus 4. So I'm going to stick that power of a half on the 2, I'm going to stick it on that bit, and I'm going to stick it on that bit. Break it up like that. Now what's the power of a half mean? Square root. So, sorry, I didn't mean to write that. 2 square rooted is the square root of 2. Yep, I will put a plus and minus in here then. Okay, thank you, that's fine. X squared, square rooted. X. Okay, so what that was there, that was x squared square rooted, which is just x. That was that middle bit. Over here I've got y to the power of 4 minus 4 square rooted. Or you may want to think, no, hang on, before that I've actually got y to the power of 4 to the power of a half, and I'll just do the power to a power thing on it. It's y to the minus 2, isn't it? So it's y to the minus 2 if you do that. Right, don't like these minus powers. Minuses are horrible. Well, how could I rewrite this so there was no minus sign? 1 over. So in other words, stick that on the bottom, like that. Now, if you were doing this and checking your answer in a textbook, it, rather than have a minus power, it would stick it on the bottom. Yes, we've done some square rooting, there should be a plus or minus in here. Now, for the sake of clarity, you need to be really careful. What are you square rooting? Are you square rooting just the 2? Are you square rooting the x as well? You are just square rooting the 2. So either put a little drop down there, make it really clear, or for the sake of clarity, write the root 2 after the x. And I know that goes against the rule where we normally write the number first. But if you wrote it down like that, there's absolutely no confusion as to whether or not the x is being square rooted. So that's allowed, yeah. So sometimes it is done like that to make it very clear the x is not being square rooted. Less confusion. Okay, we got 5 minutes, yeah, it's only one more example. I said we'd finish this in a lesson. Right, here's an equation. We are going to solve it. Right. Now, this will also bring in another chapter that we have done recently. I'm not going to say which one at the moment. So. Oh, quadratics he thinks. Okay, we'll see if he's right. Right, y Oh, let's give him a final go. Go on. Why quadratics, do you think?
Because it just looks like a quadratic.
Because it just looks like it. That's not a good enough answer. Go on, Patrick.
Is it possible to change the powers by somehow getting rid of the 3 and then you'd have x squared and 5x, or you could also...
You're heading in the right direction. I would tweak it a little bit, but you're heading in the right direction. How could you rewrite this x to the 2/3? Go on. Yes, I'm going to write it down like the cube root of x squared. We have now made this x to the power third. Well, look, the same as this. There's an x to the power third over here. We've now got x to the power third written down twice, rather than x to the power of 2 different things. That makes life easier. Now, I want to make this easier still. What is nasty about that? The x to the power of a third. Let's just replace them with something nice. Let's replace the x to the power of a third with y. Yeah, that's allowed. Okay? So, y is much nicer than x to the power of a third. So this becomes 5y equals y squared plus 4, which is a nice looking quadratic. Now, we can't, at the end of the question, we are going to have to go back into x's. Okay? But we've made it into a quadratic, and you're all experts on quadratics because you've got a test on it next week. So, if we had this quadratic, what would I do with it? Y squared minus 5y plus 4 equals 0. Rearrange it, make it equal 0. Okay, next step. Factorise it. Go on then, Jack, factorise it. Sorry?
Y minus 1, y minus 4.
So what? Someone's saying, so y equals 4 or y equals 1. Now we made y up. We can't give that as our answer. What is y actually equal to? X to the power of a third. It was this thing up here. X to the power of a third. So actually what we've got here then is x to the power of a third is 4, or x to the power of a third is 1. But if we're solving an equation, we don't want what x to the power of a third is. We want what x is. What do you do to get from x to the power of a third to get to x? You cube it. You cube it, yeah. So what is x? It's going to be 4 cubed. What is 4 cubed? 64, somebody said. It wasn't Callum this time. And over here, if I cube 1, I get 1. So there we go. X is 64, or x equals 1. That is the Indices chapter in a lesson.